Okay, so what's the deal with negative exponents? Well, the deal is this: we cannot have them. Okay? So the idea is, if we have a negative exponent, we can simply take that variable and the exponent and move it to the other part of the fraction and make it positive. So let me do it. I'm actually going to do example 2 first just to show this. So we have v to the negative 2 power. I can just move it down to the bottom and it'll become v to the positive 2, which is okay, which is what I want. Likewise, I can take y to the negative 2/3 and move that up and make that y to the positive 2/3. Now the x to the third, I'm just going to leave where it is because it's already positive. So what I'm left with after I move these is a y to the positive 2/3 in the numerator. In the denominator, I'm going to have a v to the positive 2 and an x to the third, and I have essentially made this a proper fraction. Okay, I don't have any negative exponents anymore. And now I can't multiply those together or anything because they're not the same variables. So the reason I did that one first is because you may look at the first example and go, well, where am I going to move this to? It's not even a fraction. But keep in mind that anytime you have just a number, it actually is over 1. So this is a fraction. It just doesn't seem like it at first. So I'm going to take this, move it down here, and make it positive. So now I have in the denominator x to the positive 1/2. The numerator, I'm going to put a 1 just to hold the place because I need something up there in the top of the fraction, or else, well, it wouldn't be a fraction. Okay? Now, what happens if we are asked to move some stuff and or multiply, that sort of thing? Well, the idea is this. You want to get all of your variables to one part of the fraction, do your multiplying, and then mess with negative exponents if they still exist. But be smart about where you collect all of your variables, because in our first example, it wouldn't really make a lot of sense to collect the x's in the denominator, because if I moved x squared down to pair it with x to the negative 3, well then those would both be negative. That doesn't make a lot of sense. Okay? Instead, let's take the x to the negative 3 and move it up because it will become positive. Let's take the y to the negative 1/2, move it down because it will become positive, and then we can combine these together. So in the numerator now I have x squared and x to the positive 3. In the denominator I have y to the 3/2 and y to the positive 1/2 because that moved down. And this is what I'm trying to simplify. Now I can go ahead and multiply these out. Well, in the numerator I have x squared times x to the third. As we just got done previously talking about, whenever I multiply variables, I can add their exponents. So I'm going to go ahead and add those exponents together, and that's going to give me x to the fifth in the numerator. In the denominator, I'm going to add, let's pick a different color here. I'm going to add 3/2 plus 1/2. Well, 3/2 plus 1/2 would be a 4/2, which reduces to 2. So that's going to be y to the second power, y squared. That's simplified. I can't do anything else. Now in our next example, though, it's a little different in that, first of all, we have a couple of coefficients. Now remember that even though there's no multiplication symbols, this stuff is all being multiplied together. So that 2 does not belong to the m to the 3/2. That 2 is its own thing, as is this 4. So when you see that, any coefficients you see, you can go ahead and you can reduce those like you would any other fraction. 2 over 4 would reduce to 1 over 2. Okay? Now comes the idea of, okay, where am I going to collect all of my m's so that I can multiply them together. Where am I going to collect all of my n's so I can multiply them together? Well, it's really your call. If you can't decide on whether or not you can make them all positive, all the exponents positive in one or the other parts of the fraction, just move them to one part, multiply them out, and then if you need to move a negative exponent at the end, then you can do so. Okay? Let's say I'm deciding I'm just going to collect all my m's in the numerator. So I'm going to move this one up there, and I'm going to move all my n's to the denominator. I'm going to move this one down, I'm going to move this one down so that I can multiply them together. Okay? And let me just kind of move this down a little, give myself some more room. Okay, so what I have here is I have in the numerator, I have m squared. Oops, thought I'm sorry, m to the 3/2 is already up there. M to the negative 3/4 is already up there. And then I have m to the negative 3/2 that moved up. That becomes m to the positive 3/2. Okay? In the denominator, I have an n to the 4/3 that was already down there. I have an n to the 1st that came down from the numerator, and I have an n to the negative 1 or to the 1/2 that comes down and has to become negative because I moved it to the other part of the fraction. Okay, so this is now ready for me to do some multiplying. Okay, I have to get all that to the same part of the fraction just so that I can multiply. And then, like I said, if there are any negative exponents left, then we'll just simply move it back. But the first order of business is to multiply these m's all together. And what I have is I have 3/2, a negative 3/4, 3/2, plus a negative 3/4, plus another 3/2. Because remember, whenever I multiply variables, I add their exponents. Common denominator, let's make that common denominator 4. The negative 3/4 isn't changing. 3/2 is going to become 6/4, as is this one over here. Okay, and the way that I got that, I just multiplied top and bottom by 2, so that they had the same denominator. Okay. So if I add numerators together, that becomes 6 plus negative 3 is 3 plus 6 is 9/4. So this is going to be m to the 9/4. And that's positive, so that can stay there. That's good. Okay. In the denominator now I have to add all these together. 4/3, 1, and negative 1/2. So 4/3 plus 1 plus negative 1/2. Well, I got to come up with a common denominator. I suppose I could use a denominator of 6 for all these. Okay. To change 4/3 to a denominator of 6, I would have to multiply top and bottom by 2. That's going to leave me with 8/6. 1 is the same thing as 6/6. And then here, if I multiply top and bottom by 3 to get a denominator of 6, this is going to be negative 3. And when I add my numerators, 8 plus 6 is 14. 14 plus a negative 3 is 11. So this becomes n to the 11/6. And I kind of lucked out because I do have positive exponents, so I don't have to move anything. All right. So get all the variables into one part of the fraction, multiply it out, and you're good from there. Okay, last thing here for this little video. I'm going to go ahead and I'm going to take care of this down here first. Okay, the highlighted part. I got to simplify that first because I got to do exponents before I do any multiplying. So I'm going to go over here and ask myself, okay, what is x squared to the 2/3 power? Okay. Remember, when I have a power raised to a power, I can multiply. So that's like saying 2/1 times 2/3. That's going to be an x to the 4/3. So really, this now becomes x to the 4/3, y to the negative 1/4, with an x to the 4/3 down here. Okay. Now I got to get all my x's together, all my y's together. I know I'm going to move this down because it needs to become positive. For the sake of combining, I suppose I ought to take this and move it up, and then I can actually multiply those x's together. So what I have now is I have y to the positive 1/4 because that moved down, and in the numerator I have x to the 4/3 that was already up there, times x to the negative 4/3. Okay? And I know when I multiply fractions, I add their exponents. So when I do 4/3 plus a negative 4/3, I get 0/3. So this becomes x to the 0 over y to the 1/4. Well, this is a tricky little thing to remember here. Let me kind of box this off here. It's a tricky little thing to remember, but anything to the 0 power, like we have here, is just equal to 1. Okay, anything to the 0 power is equal to 1. So really this ends up being 1 over y to the 1/4 power. Alright, that's probably something you want to write down in your notes. Anything to the 0 power is equal to 1. So what we did here was we moved variables so I could combine. When I combined my x's, I got x to the 0. Well, anything to the 0 power is equal to 1, so we put a 1 in its place, and our denominator just remained 1 y to the 1/4 power.